Hi there. So this is question B. So let me start by writing my solution. I want to solve question B. So like you all know, I want to solve this linear system here. So sometimes it might be confusing. You might not really know whether it's a homogeneous or a non-homogeneous. But to make it very clear, it's always good to start by writing the linear system in matrix form. So you're writing in the matrix form. What I have here is x prime equals, now the coefficient here is 2, 1, 2, 3, 0, 6, since we do not have any y, and then the next one is minus 4, since there is no y, write 0, and the coefficient of of z is negative 3, then times x. So now it becomes very clear that it's a homogeneous system. So that was the first thing we did. And the next thing is you identify your coefficient matrix. So the coefficient matrix here is 2, 1, 2, 3, 0, 6, negative 4, 0, negative 3. Now having done that, the next step you want to do is you want to find the eigenvalues of the coefficient matrix. So the eigenvalues simply implies you want to solve the characteristic equation of A. So that is, you want to solve A minus lambda I, which is equal to, and we said A minus lambda I is just deduct lambda from all the diagonal entries. That's the fastest way to see it. So you have 2 negative lambda, you have negative lambda, you have negative 3 negative lambda, you have 1, 2, 6, you have 3, negative 4, you have 0. This is what you have. And then is equals 0. And when you find the determinant of this matrix, what we're going to have is you have lambda cubed plus lambda squared minus lambda plus 15 equals 0. And then when we solve this cubic equation here, we obtain so we're going to obtain lambda 3, let me see, lambda 1, lambda 2 equals 1 plus or minus 2i, and our lambda 3 equals negative 3. So because we're solving a three linear homogeneous system, so we're expecting that our solution should be of this form: x equals c1x1 plus c2x2 plus c3x3. So where x1 is the solution that corresponds to the first eigenvalue, x2 is the solution that corresponds to the second eigenvalue, and then x3 is the solution that corresponds to the third eigenvalue. Or probably lambda 1, lambda 2 are the same, or lambda 1, 2, 3 are probably the same, or whichever the case may be. But what's most important is that x1 and x2 and x3, they must be linearly independent. That's very, very important for them to form a general solution. So I'm going to start by going ahead to find the eigenvector that corresponds to lambda equals negative 3, since it's the real part and it's always quite easy to find. So that brings us to part 4. So I want to find the eigenvector. So I'm going to solve A minus lambda I x equals 0. So I want to solve this for lambda 3 equals negative 3. So for lambda equals negative 3, my A minus lambda I x is just going to give me, so we are deducting, so wherever we have lambda, we replace it with negative 3. So 2 minus minus 3, that is 5, 1, 2, so the same thing, 3, 3, 6, then the same thing, negative 4, 0, 0. So we have this, and we have, so this should be this. It's actually brackets, so it's not determinant, times x, y, z. So this is what we want to do. Now equals 0, 0, 0. So we want to solve for x there. So like we know, we need to row reduce the coefficient matrix there. And then when we row reduce that, what we obtain is 1, 0, 0. We have 0, 1, 2. We have 0, 0, 0. This is exactly what you obtain. This is x, y, z equals 0, 0, 0. And then when we write this in equation form, 1 times x, that is x equals 0. 1 times y plus 2 times z, that is y plus 2z plus 2z equals 0. And what you observe here is the free variable is z. So since the free variable is z, I'm going to set my z to be 1. So my z is 1, my y is going to be negative 2, and my x is 0. So I can find the eigenvector, which is going to be x, y, z. Now that is the eigenvector that corresponds to lambda equals negative 3. Now to find the solution that corresponds to that, you could just simply rewrite it as, so you have x3 equals, so let me call this k3 since we are calling it lambda 3. So x equals k3 e to the power lambda 3t, and that is 0, negative 2, 1, and e to the power lambda 3t is negative 3t. So this is the first solution we have gotten here.